Today I will be providing you with a brief overview of data mining. So let's start with a review of the definition for data mining. Data mining can be defined as the automatic extraction of interesting patterns or knowledge from large amounts of data. It involves methods that are at the intersection of artificial intelligence, machine learning, statistics, as well as database systems. Let's talk about some examples of non-trivial data mining results. One example, which is a very famous one, was the pattern that was found where people who are going in to buy diapers, which are typically going to be men who get sent to the store to buy the diapers, also tend to buy beer. So beer and diapers tend to be bought together, often by customers. And again, typically it's going to be the male customer that's going to be buying diapers and beer. Another interesting example here is Phoenix. It's not going to be a good place to sell golf clubs, despite many golf courses that are nearby. And so this tends to be a little bit counterintuitive, but this is what the data shows us. Another one is that people who buy those small pads that adhere to the bottom of your chair legs tend to protect your wood floors, tend to be good credit risk. So if you can find out that one of your customers is doing that, it's going to be a good indication that the customer is going to be a good credit risk. Another interesting one is that vegetarians tend to miss fewer flights. So again, these are non-trivial data mining results that can be impactful for a business if they're going to be properly used for whatever that particular situation is. So what are some common data mining techniques or tasks that are used? So among them are classification and class probability estimation. We will be doing a lot of this in the course. An example of this would be to determine which class an individual belongs to. Are they going to be in a good credit risk category or a bad credit risk category? Another one will be regression, and there are many regression extensions. So not just simple linear regression and multiple linear regression, but there are many extensions of regressions that are available. So we have an example of estimating a numerical value of some variable or individual would be that you might want to estimate the amount of income that an individual makes given a certain number of characteristics. Similarity matching would be identifying similar individuals based on known attributes. So you'd be trying to find similarities among different groups or individuals. And another one that's somewhat related but not exactly is going to be clustering. This is where you group individuals together by similarity. So let's talk about an example where we could be looking at customer retention. So a firm may be looking at which customers they should target with a special offer prior to their contracts expiring. That's going to be something that many companies do to try to manage the lifetime value of their customers, where they're trying to identify customers who may not be very likely to return to them when their contracts expire. And so the company may want to look for some behaviors that might indicate this so that the company can incentivize them with a special offer to stay or to make a new contract before the customer tries to terminate it. So many of you will have this happen with your cable or your phone services where you try to cancel and then you go through this process, but sometimes they'll give you a pretty good deal prematurely before you actually take any action, where they're just trying to get you to extend your contract by a couple years, and they'll give you some kind of carrot to do that. So again, your firms are trying to identify customers who may be at risk of defecting, and they are trying to retain them through special offers. So once again, that would be an example of the result of a data mining type of exercise. Some examples of data mining techniques that we might see include a decision tree technique. An example of that would be if education is high and gender is male, then the customer is likely to churn. So it follows an if-then statement format. So if, once again, if the education for the person is high and the gender for the person is male, then we're going to predict that yes, the customer is going to churn. A logistic regression technique will be another example that we have. And what we do is we calculate the probability of churning given the features of that customer. And then another example is the nearest neighbor technique. And in this example, we calculate how similar our customer is to existing customers who have churned. And so these are just a couple of examples, and there are many, many more types of techniques. Some of the common approaches to data mining is the CRISP-DM process. This data mining process is very heavily used in the industry, and it's a process or framework that we will be utilizing in our discussions of data mining. So as a brief overview, it starts with a business understanding. What are you trying to solve? What does success look like? What is your plan? And all that relevant information is going to be related to understanding what the objective is. Next is your data understanding. You always want to have some foundational understanding of your data. And so typically we will call this phase the exploratory data analysis. Things then that typically will lead to some form of data preparation that you will go through. Then we will do some modeling, and we may go back depending on what we find in our modeling. For example, we may find that the variance in our errors is not equal, and we need to do some data transformations to try to get rid of some of these unequal variances in our errors. Then you will go to evaluation, and this will be a key thing we will do in data mining. And we will talk much more about this here in today's discussion around validation and evaluation. So this is a critical step in data mining process. Then there is the deployment phase, which will be typically actually taking that algorithm and making some business decision. But it also entails communicating your insights to others both verbally and in writing. And this is often one of the most important steps in the whole process, because ultimately we need to convince someone to take action on the insights that we derive from the data. So let's go through some basic terminology related to data mining. So here we obviously have the data. We have a target variable, we have model, and then there are types of problems that we may face. You can have a classification type of problem, so you could be asking, are they going to churn or not? You can have a regression type of problem where you're trying to predict a continuous variable, such as what income that individual will make, where you're trying to predict a continuous variable or a continuous outcome. And then we have training versus validation versus testing data. When we train our models, we use the training data set, and then we validate that the model is not overfitting and that it is performing well on a set of data that it has not yet seen. Then we call that our validation data set. Then oftentimes, especially if we have an update, we will have a third segment of our data which we will use for additional testing to see how it does when we add additional data to our model. So for the purposes of learning about data mining, we will stick to training and validation data sets. But if you do have a large enough sample size, it is often advisable that you split it up into those three groups: training, validation, and testing. And then you have two forms of data mining techniques. We have supervised and unsupervised learning. In this class, we will be looking at both of them, and primarily we will be focusing with supervised learning. So what is supervised learning? The goal is to predict a single target or outcome variable so that we have a defined target variable that we're trying to predict, whether it's binary classification or a continuous variable that we're trying to predict. We will have training data where the target value is known. Therefore, the Y values are known for each case, as well as the X variables that would be used to predict our Y values. We need to have labels to describe our target variable in our training data. These values will be used to develop a model that you will score the data for the value of your outcome variables or your Y variables that are not yet known. Some of the methods we will use for supervised learning encompasses both classification and prediction type of problems. Again, with prediction, we will refer to that when we are trying to predict a continuous variable, and classification could be binary or even more than binary. You can have 3 or more classes that you're trying to predict as well. So the gist of it is in supervised learning, your X's and your Y's are predefined and labeled, so you know exactly what you're trying to predict, and in this case, it's usually some Y outcome variable. In unsupervised learning, the goal is to segment the data into meaningful segments to detect a pattern. And so there's not going to be a target outcome variable to predict or classify. So you're not going to have any X's or Y's. And in this case, you're going to be working with all of the data. The methods that you will typically see here are going to be association rules, such as k-means clustering and hierarchical clustering. Data reduction, such as principal component analysis, and then also visualization. Going back to our data, it is important to understand how we will be discussing and labeling our data. So in this case, let's look at an example here where you have a data set with name, balance, age, and whether or not they defaulted. And so you will have a factor or a data point that is described by a set of attributes. In this case, the attributes are, you're going to get the name, balance, age, and whether they defaulted or not. So this is the set of examples that we have for multiple observations. Here we have Mike, Mary, Bill, Jim, Dave, and Ann. You have one instance here, for example, Mary. So Mary had a balance of $51,100 with an age of 40, and yes, she defaulted. When we're looking at supervised learning problems, we are always trying to predict some target variable. In this case, we're trying to predict whether they defaulted or not. So this is our variable of interest. Things to keep in mind when we talk about attributes. Remember, attributes are the word that we use for variables. So the attributes we are looking at could be the balance and the age, and then the target variable would be the dependent variable. So the dependent variable, again, in this case, is going to be whether they defaulted, yes or no. Now let's talk about the types of attributes or variables that we may have. You could have some numerical quantitative data, including discrete data, that has only a finite or countable infinite set of variables. So these are going to be integer values. For example, the number of items bought by a customer could be 12, 1, 2, 3, 4, 5, or any other number. But it is not a fraction of a product. It's always going to be a full integer. You can have continuous variable that has real numbers as attributes. An example that could be the time the customer spends at a store. For example, it could be 16.49 minutes. And if you want to learn more about the type of variables, there's a link here that I have for you that goes to a YouTube video on this. But again, when we're talking about the types of variables we are looking at, especially when we are talking about our dependent variable, the type of variables that we are looking at, whether it is discrete, continuous, binary, or so forth, will have a significant impact on the type of algorithm we can utilize. That's why it's going to be important that you identify the type of variable that you have before you start to plan how you're going to analyze your data. Some algorithms are better suited for continuous variables, while others are designated for categorical data. So let's talk about categorical types of variables. Categorical variables are going to be qualitative data. They can be ordinal variables where the categories have meaningful order. Your grade that's going to be printed on your transcript is an example of that ordinal qualitative variable. With your nominal variables, the categories do not have any meaningful order. So for example, it could be the state that the individual resides in, such as Texas, California, Alabama, and so forth. A model is going to be the pattern that we see in our data. It's going to be a summarization of the relationships in the data, and it's a simplified representation of the reality created to serve a specific purpose. So some example here would be if we look at a decision tree. If the balance is over $50,000 and age is over 45, then you could predict that they're not going to default, else their default value would be yes. So this would be an example of a model that we could create, and it's showing a pattern that summarizes a relationship in the data. Another term that I would like to define is learner. Learner is an algorithm or a method used to generalize a model for a set of examples. So in this case, staying with the same example we are looking at, you have your data set here. We are trying to predict default. With the learner, we are trying to induce a pattern from the examples. Then the pattern we derive is this: if the balance is greater than or equal to 50,000 and age is greater than 45, then default is no, else it equals yes. So in practice, people who use model learner, they tend to use them interchangeably. So if you hear the word learner or model or algorithm, they're typically going to be talking about the same thing. Going back to supervised versus unsupervised learning, in supervised learning, you are trying to do some prediction. You are trying to learn a model that predicts a target outcome based on a set of other attributes. In this case, a training data where a target value is known. An example would be stock price prediction when you have a numerical target variable, credit card default, and you have a binary outcome. In unsupervised learning, you are trying to do relationship mining. You are trying to find relationships in your data without reference to your target variable. So going back to our earlier example of beer and diapers, people who are going in to buy beer and diapers tend to buy them together. So that's going to be a relationship that has been identified. In that case, there wasn't a dependent or independent variable. It was just a relationship that was identified. So the bottom line is the key is going to be to determine if the target that we're trying to predict, right? If there is, that's going to be supervised learning. If there is not a target that we're trying to predict, that would be your unsupervised learning. Let's talk about prediction versus classification. The difference is the type of target variable. In classification, you have categorical target variable. So if your customers are loyal, are they likely to terminate their contract? Is a credit card use going to be legitimate, or is it going to be fraudulent? With regression or predictive type of situations, you are looking at a numerical target variable. How much customers are going to spend and what was the credit score of a customer are all examples of this. So here when I talk about regression, it could apply to other types of extensions of that as well. There are many different types of models that can be used to try to predict numerical targets. Both of these examples are supervised learning because you had a defined outcome that we are trying to predict, and a y value is our set predictor variable or attribute that we're typically labeled as x. So let's talk about data modeling philosophy. Typically you have some data to start with. We will then build a model, and then we will use that model to apply new data that we haven't seen yet. So that's typical of what we're trying to do. We would be trying to predict some outcome. In this case, it would be default. And then we collect new data. We're trying to then predict if that customer is going to default or not using the model that we created. When we evaluate our model with supervised learning, it's going to be grounded on truth, meaning that we know what the final answer is. Does John default on his loan? Yes or no? You already have a definitive answer. So it is grounded in truth, and you know what the answer is when you are working with your training data. And for evaluation, we are looking at the predictive performance of the model. So how accurate is your model in predicting that outcome? We will talk about the different types of performance measures in a later discussion. But that's what we will evaluate in predictive performance of those models to evaluate how well it is doing. For unsupervised learning, it is not grounded in truth because there is not a predetermined output that we are trying to predict. So how you evaluate how good your unsupervised learning model is really how easy it is to understand. Can you derive some meaning out of that unsupervised learning model that can be used for your ultimate purpose that you embarked on for your data mining project? So let's talk about model training versus model testing. Here's the problem. After learning a model, can we have an estimate of how well the model will perform on new data or data that it hasn't seen yet? So really, we do not. So what we need to do is we need to split the data into two parts. We will have our training data that we will use to learn the model or to train the model. Then we will have our testing data to evaluate the performance of the learning on the new data. The one thing to keep in mind is you never ever use your testing data to learn your model. So what does that mean? When you split your data into training and testing, you do not use the test data to learn your model. So why do we want to split our data into two parts? Well, the answer is fairly simple. Basically, it comes down to the fact that whatever you use to train your data, that is what is going to be used to derive your pattern. So when you measure the performance of a model on the training data, of course it's going to do well and perform well because that is what it was used to learn the data. It is equivalent to a situation if I gave you all an exam ahead of time and then turned around and gave you the exact same questions. So of course everyone should do well if I've already given you the answers in the order that they're going to be asked. So similarly, a model that has seen the data before and it's going to do well in predicting, and it's going to tend to overfit the data, meaning it's going to guide you to include more variables than you likely may need. And therefore it means it's going to be overly optimistic on how well the model is doing. So you want to split your data into two, a training data set and a validation data set or a testing data set. So let's be specific as to what this looks like, just to be crystal clear on this. Here is our data set, and then we are going to take a random selection of that data set and use that as a training set, which is what we will then use to train or fit our model. Then we have our testing data set. Again, it could be called your validation data set as well. That's the holdout data set that will be used to see how well the model that we train performs on that data set. Specifically, we will use the training data set to train our learner algorithm, and then that pattern or model that we extract, which is what we have here, is what we will then use to try to predict the testing data set. So here we have these two individuals, and in this case we apply the algorithm. And then here is our predicted versus our actual confusion matrix. Then we can evaluate the effectiveness or performance of our model using the holdout testing data set. Let's talk about test versus training data set for supervised versus unsupervised learning. So what we have just talked about, the split into training and testing data set, that really applies when you are doing supervised learning. So the learner is given the training data set, and then you evaluate the performance of your model on the testing data set. But for unsupervised learning, again, because there is not a predisposed outcome you're trying to predict, you really don't need to split your data. You just fit it on the entire data set, and there is not any splitting. Then you are fitting your model and evaluating your model using your training data set. So what this looks like from beginning to end is you start with your data, then the training and testing data in this set will have some known values of targeted attribute. If we are doing supervised learning, then you do your data mining to extract a model. Then you use that model to then try to predict a new data set. So now you are moving from the data mining phase to the using phase or deployment phase. So you have some new data that you have that has been generated by your processes, and then you are trying to use that model that you derive from your data mining process to then fit it into the new data to try to derive a prediction. So is that customer going to churn or not? Or is that customer going to default based on the target attributes that you have identified? And then you are trying to make a prediction. So an example of data mining project would be our telco data set that we have. It's a major telecommunications firm. They want to investigate a problem with customer attrition or churn in a saturated market. A large portion of cell phone customers leave when their contracts expire. So the question that the business has is, which customers should they target with a special offer prior to contract expiration? So think about it and try to come up with, in your mind, what would be that data-driven solution to the problem. Use some concepts that we have discussed to try to formulate what kind of project this would look like. So what would be the high-level plan for this type of project? One question I have for you is, given this problem, what would be the first step that you take in this process? So if we already have a defined objective or a problem that we want to solve, what should be the first step you take? So I recommend that you pause this video to come up with an answer to this question. So now that I've given you some time to think about it, here's a quick summary of it step by step. In this case, we already have a defined business objective. So the first thing we should try to do is determine the target variable that we are trying to predict. In this example, it will be customer churn. You would want to find the available attributes of the customers. So what are the different attributes you have access to that you can use to potentially predict your outcome? You find that the data set is comprised of both independent variables and the target variable. So you will then aggregate all of your data. You can split your data into training and test data set. You can train the models based on the training data set and evaluate them on the testing data set. You can choose the model with the best predictive performance. If you're looking at customer churn, you're going to want to use the data that you have for the customers who have churned as your exemplars to train your model. And then you are going to test your model to see if it accurately predicts your customers who churn from the testing data set. In the next step, you are going to use the best model trained in step 4 to predict the churn behaviors of new customers whose churn behavior is not yet known. So before they actually churn, you're trying to identify them. Then you're going to send your promotional offers to those customers who are predicted to have high likelihood of churning in an effort to try and retain them. So again, this was just a quick overview of the data mining process and some of the foundational concepts and nomenclature. So circling back to the data mining process, which again, we'll use the CRISP-DM framework. Number 1, you're going to define or understand the purpose of the project. Then you're going to get some data, could involve some kind of random sampling. Then you're going to explore, clean, pre-process your data. Step 4 is going to be reducing the data dimensionality. 5 would be looking at your specification of your data mining class, if you're going to do classification, clustering, so forth. Step 6 would be partitioning the data if you're doing a supervised approach. Step 7 would be choosing your techniques such as regression, CART, neural networks, and so forth. Number 8 would actually be doing the task. Number 9 would be interpreting and assessing the model, comparing the models and selecting the best model. And then step 10 would actually be taking those recommendations and putting them into action.